So example number 1, use the method of undetermined coefficients to solve the differential equation d squared over dx squared plus 5 dy over dx plus 4y is equals to 0, given that when x is 0, y is 0, and dy over dx is 1. Now the first thing in the method of undetermined coefficients, that is the d operator, method. So it means where there is d dx, we replace it with the d, isn't it? The d operator method. That it will implies d squared is going to be d squared over dx squared from our equation, isn't it? Are we together? So in the first one here, d squared over dx squared is d squared. Then it is now d squared times this y, which is here, isn't it? So it is d squared of y, it is d squared of y plus 5, d dx is d, so it is d of this y, isn't it? Are we together? It is d of that y plus 4 plus 4y to be equals to 0. Are we together? To be equals to 0. Then from here, we now, because this d operator is a derivative, isn't it? So we replace it with m to get the auxiliary equation. So if you let d to be equals to m, where there is d you put m, so here we're going to have m squared y, then plus 5my, then plus 4y to be equals to 0. Are we together? Having done that, you can see y is a common factor. So if you factorize out a common factor, you remain with m squared plus 5m plus 4 is equals to 0, doesn't it? Yes. So from this it implies if you have a product of two factors which is equivalent to 0, then it means either the first factor is 0 or the second factor is 0. So either y is 0 or the second factor, which is m squared plus 5m plus 4 is equals to 0. So when y is 0, it means our second order homogeneous ODE does not exist, doesn't it? Are we together? So the second equation is the auxiliary equation. The second equation is the auxiliary equation. So our auxiliary equation, we found m squared plus 5m plus 4 is equals to 0. So from here, you can now solve the quadratic equation, isn't it? So this is in the form am squared plus bm plus c is equals to 0, isn't it? So you can see your a is the coefficient of m, which is a silent one, isn't it? Your b is the coefficient of m squared, gives you a, the coefficient of m is b, positive 5, isn't it? Then you will see the constant term is positive 4, which is just 4, isn't it? So if you substitute this in the quadratic formula, you get m to be minus b plus or minus square root of b squared minus 4ac over 2a, isn't it? Are we together? So do the substitution, minus b is 5, so that is minus 5, isn't it? Plus or minus square root of b squared, that is 5 squared, you get 25. Then it is minus 4ac. 4 times a times c, 4 times 4 is 16. 16 times 1 is 16. Over 2 times a, 2 times 1, over 2. Are we together? So what do we get here to be m? So m is what? 25 minus 16, c root 9. What is root 9? So it is plus or minus 3 over 2. So it means we have two solutions of m, isn't it? So the first solution of m1 is what? When it is positive, you block the negative. So it is going to be negative 5 plus 3 divided by 2, isn't it? Negative 5 plus 3 is negative 2 divided by 2. You get the first solution to m to be negative 1. Are we together? Then the next solution of m2 is going to be, you block the positive in the middle, so it is negative 5 minus 3, which is negative 8. Divide by 2, you get negative 4. So what have you found? You found two real solutions, isn't it? So from the two-ring solution, you check your differential equation. From your differential equation, you are differentiating y with respect to x, isn't it? So if you are differentiating y with respect to x, it means y is a function of x, isn't it? So it means the solution of this ordinary differential equation, when you have two real solutions, then y is going to be what? A exponential m1x plus b exponential m2. See, if you have two real solutions, so the first real solution, the second real solution, isn't it? Are we together? So can we now do the substitution? Let us do the substitution. If you do the substitution, what do you have? You have y is equals to a exponential m1x, but m1 is negative 1, isn't it? So that is exponential negative x, isn't it? Yes. Then it is plus b exponential m2x, but m2 is negative 4. So it is minus 4x. So you see, this is the general solution of the homogeneous second order ODE, isn't it? But we want solution when x is 0, y is 0, and dy over dx is 1. Are we together? So it means for you here, where there is x, if you put 0, where there is y, you also put 0. Because we want to know the value of a and b, those coefficients, isn't it? So when x is 0, where there is x, if you put 0, where there is y, you put 0, isn't it? So you end up with the first thing you get here is, where this y, if you put 0, exponential 0, anything raised to 0 is 1, isn't it? So you end up with 0 is equals to a plus b, because exponential 0 is going to be 1, you remain with a, exponential 0 is going to be 1, you remain with plus b, because 0 times anything negative 4 times 0 is 0, so exponential 0, isn't it? Are we together? So the first relationship here, we found that a plus b is equals to 0. The second one, you can see dy over dx is 1. So here you have y as a function of x. So for you to get dy over dx, it means you differentiate this equation. Are you seeing that? If you differentiate y with respect to x, so you get dy over dx. So if you differentiate exponential negative x, you get what? Negative exponential negative x, because differentiating exponential negative x, it remains the way it is, isn't it? Then when you differentiate the inner function, which is negative x, you get negative 1. That is why our negative is here. Are you seeing? Then you go to the second one. If you differentiate exponential negative 4x, it remains the way it is. Then if you differentiate this inner function, negative 4x, you get negative 4, isn't it? So negative 4 times b, so you get negative 4b. Are we together? So after getting dy over dx, you are being told here, when x is 0, dy over dx is 1. Meaning where there is dy over dx, you put 1. Where there is x, you put 0. So if you put 1 here, what do we have? An exponential 0, anything raised to 0 is 1. You remain with minus a minus 4b. Remember, exponential 0 is 1, exponential 0 is 1, isn't it? Are we together there? Are we together? So we now have the two equations. That is the first equation. That is the second equation. Are we together? So start. How do you solve this? You can use any method. Substitution or elimination, isn't it? So the first equation here may be if you let a to be equals to minus b, because positive b coming this side, it becomes minus b, isn't it? So from the first equation, a is equals to negative b. So it means where there is a in the second equation, you put negative b, isn't it? So here we have 1 is equals to negative a, but a is the same as minus b. Then it is minus 4b. So can you simplify? Open that bracket. 1 is equals to negative. The negative is positive, isn't it? So we have b minus 4b, isn't it? b minus 4b is c negative 3b. So for you to get b, what do? So you divide both sides by negative 3. Then you get b to be negative 1 over 3. So once you found b to be negative 1 over 3, what is your a? Your a is negative. See, your a is negative b. So a is going to be negative of negative b, negative of negative 1 over 3. Negative 1 over 3 is b. So that is negative b, isn't it? Negative into negative is positive. So you get a to be a third. So what is the solution of your differential equation? So the solution is y is equals to a, which is 1 over 3 exponential negative x plus b, and b is negative. Are you seeing this? B is negative 1 over 3 exponential negative 4x. So this is the solution of the second order homogeneous ordinary differential equation using the D operator, or the method of undetermined coefficients. Are we together? Good.